Okay, this is question number 8 from section 6.2, and it's for Math 10 Honors. Okay, so in this question here, you have 1, 2, 3, 4, 5, 6 numbers you can pick from, and you multiply 3 of them together, and you're being asked to how many different possible products you can have. Okay, the only problem is for this question is certain numbers can overlap, like certain products can overlap. So first step I would do, number 1, is you write each of these numbers in their prime factorization. So here's like 2, you have like 3, and then 4 is like 2 squared, and then 6 is like 2 times 3, and then you have 8, which is 2 cubed, and then you have 12, which is like 2 squared times 3. Okay, so there's 6 of these. And what I'm going to do is I'm going to write all these with the ones with powers of 2s and the ones that include 3. So you have like 2, you have 2 squared, and then you have 2 cubed. So these ones have only 2s. And then the ones with 3 with like 3 to the power 1, and there'll be like 2 times 3 to the power 1, and then you have 2 squared times 3 to the power 1. Okay? And what I'll do is I'll name this one as A, this is B, this is C, this is D, this is E, and this is F. Okay? Now, the second thing is, when I look at all the different products, every single product is going to be, okay, number 2, all products are going to be in the form of in the form of 2 to the power m times 3 to the power p. 3 to the power p. Okay? So no matter what you do, they're always going to be in this kind of form. So, but the thing is, when you look at p can only be from 0, 1, 2, or 3. These are the possible exponents for 3. Okay, it could be 0, 1, 2, or 3. So since there's only 4 different exponents you can have, what I'll do is I'll use p to split into separate cases. Okay. For example, let's say if number 1, if p equals 0. If p is 0, that means that you can't use any of these. Like you can't use like D, E, or F, like the ones with any powers of 3s. So they all have to come from this one here then. So since there's only 3 of them, you must pick 3. So therefore, there's only one case. Okay? So if you have like 3 to the power of 0, you could only have 2 to the power of 3, 4, 5, 6. 3, 4, 5, 6. Yeah, 2 to the power of 6. And this is the only possible case you can have. Okay? Number 2 is, let's say where p is equal to 1. P is equal to 1. So that means that you only have one of these, one from this column, and then you must pick 2 from this column. Okay? So one way is to look at the exponents where, let's say you have 3 to the power 1. Okay? 3 to the power 1. So the lowest you can have is, if you pick like D, A, and B, which is like this one, and that one. So it will be 2 to the power 3. So that means that this is the lowest power of 2 when it's 3 to the power 1. And then if you keep on going, okay, let's say the biggest one, 3 to the power 1. So the biggest power for 3 to the power 1 is where I would use this one here, 2 squared, and with this one and that one. So I'll have 2 squared, 2 cubed, and 2 squared. So 3, 4, 5, 6, 7. So 2 to the power 7. Okay? And so you count this. That means you can have 2 to the power 4, you can have 2 to the power 5, 2 to the power 6. 1, 2, 3, 4, 5. All times 2 to the power 1. So altogether over here, there's 5 cases. So 5 cases. Okay? And then what I'll do now is I'll go through my third case. I'll do third case, where p is equal to 2. Okay? So p is 2. That means that all you have to take 2 of these, and only one of them, one from the no 2s. Okay, so you will have p is 2, so 3 squared. So if I take 2 of these ones from the right column, and I want to find the smallest one, so it'll be like DE with an A. So DEA. So that means it'll be 2 to the power of 2. So there's 1 and then that one, so it'd be 2 squared. Okay? And then let's say we want to find the biggest one. I'll take these, like from the right column, I'll take 2. I'll take these 2. So it'll be like 2, and I'll take this last one here. So I'll take FEC. So FEC, it'll be 3 squared times, so 2, 3, 4, 5, 6. So 2 to the power 6. Okay. And that means in between you can have 2 to the power 3, 2 to the power 4, 2 to the power 5. So 1, 2, 3, 4, 5. So 5 cases as well. 5 cases. And the last one is, hey, I want P to be equal to 3. And that means that I must take all these 3. So there's only one case. So altogether, the number of possible, so the number of different products will be equal to 1 plus 5 plus 5 plus 1. That gives you 12 cases. Okay, that's it.